During the next few sessions, I want to take you through analyzing some of the common protocols you'll see every day as both a system administrator and a security administrator. I want to start off by looking at FTP, the File Transfer Protocol. After FTP, we're going to move on to a series of other protocols such as Telnet, HTTP, and so forth. First, let's look at File Transfer Protocol. Now, FTP is one of the oldest and most popular TCP/IP protocols. It's been in the TCP/IP family since TCP/IP came out. Now, traditionally it's been probably the most quick, efficient, most common way of transferring large numbers of files and large size files across networks, both internal LANs and across the internet. Now, as a network administrator, you probably know that FTP uses port 21, but it also uses port 20. One port is a control port, the other port is a data port. Now, you may have heard this also before, but FTP is considered an insecure protocol, and I'll show you why in just a moment. But basically, FTP does not encrypt anything. Everything is sent across the wire in plain text. So any data that's sent across can be intercepted by using a sniffer, a protocol analyzer, or whatever. Let's go ahead and take a look at File Transfer Protocol, and we'll just do a quick analysis of it, and I'll show you kind of how it works and kind of how it's set up. We're in our Windows XP virtual machine, and I've got Wireshark started. I'm going to go ahead and start a capture. And I want to be able to show you an FTP session, just a quick little bit of an FTP session. Let's go ahead and minimize Wireshark. And let's just come down here to the command line in Windows XP, and we're going to try to connect to an FTP server. We're going to put our username and password in. I'll just show you how the connection goes in Wireshark. So we've started our FTP client, and it's asking us for a username. Now, I already have a username and password set up on the server I'm connecting to. We're going to call it tuser, and it's going to require us to put in the password, and we will put in the password. And I'll tell you right now, the password is going to be transmitted across in plain text. I'm not going to tell you what the password is immediately. We'll find that out in just a moment. So let's say we've FTP'd in, we've done a couple of transfers, we've done a couple of directory listings. Now let's quit. And just that simple short FTP session generates a lot of traffic. Let's look at the traffic and see what we get. Okay, we could go through the traffic and look at it packet by packet, and that's very useful actually to do sometimes, so you can kind of get the gist of what's going on. But you can also do what's called a session trace, and I'll show you what that is in a moment. Let's go ahead and look at it packet by packet first though. We have a standard ARP broadcast, and as you've probably figured out by now, most network communications start with an ARP. There has to be some kind of resolution between the IP address and the MAC address, so ARP takes care of that. Then we start our FTP, and we can look at the FTP session over here, and let's go to our first packet here. And if you just look down here, we can look at the TCP protocol, source port 1066 from the Windows XP machine, destination port FTP, port 21, and we get the standard SYN ACK three-way handshake, and then we've got a reply back, of course, and then we start FTPing, okay? And we get a banner here, Microsoft FTP service. By the way, if you're ever scanning and come across a Microsoft box running FTP, it's actually easy to do banner grabbing, so you can see that helps you determine what operating system the host is if you didn't already know. But here's something interesting. After our standard overhead with getting the connection going and everything, here's the user request for the password. Now if you look down here, the password is listed in plain text. You can look at that in the ASCII representation down here in the bottom pane, but you can also see that actually in the packet itself. If you look right below that is the password request, okay, that comes across from the server. And looking down here a couple more packets, guess what we see? What do you think that is? VTC is great with an exclamation point. That's actually the password. And if you look right down here in the ASCII representation, you can see that right there. You'll see the word pass right before it, and you'll see VTC is great, exclamation point. So that kind of shows you right there why FTP is insecure. It would be easy for someone to sniff the FTP session and get the password. That's why you'll find that actually if people are going to use FTP, let's say for driver downloads for example, you want to use it so it's configured to run anonymously. In other words, no password or username is required. That way, there's no threat of revealing a password, because face it, a lot of people use the same password for multiple systems. So if you required a password and that password was sent across in clear text, it might be the password for another system as well. So if you're actually going to use FTP out in the real world, I would recommend that you use anonymous FTP. Looking on through here, there's other things we can see. It tells us that the user is logged in. We're still seeing our sequence numbers, our ACKs, and all that, the TCP communication overhead. We've done a port request here, port command successful, a list. And so some good stuff that's going on here. Not too much to talk about other than just the overhead. The main thing I wanted to point out to you was the fact that the password and username are set in the clear text. And that demonstrates why FTP is such an insecure protocol. Now, there are alternatives using FTP, such as Secure Copy, and some other alternatives out there, and you definitely want to use encrypted communications whenever security is important. Don't rely on unsecure protocols such as FTP. The other way I want to show you this capture is called following the TCP stream. And if we click this and we look at it, let's take a look at here. This basically shows you almost word for word what happened on the screen here. If we follow the TCP stream, we see that the banner came back, the user put in their password, the banner came back and said password required for T user. We put in the password, VTC is great, exclamation point, and it gave us the status here. Right up until the quit command, all those packets that we saw basically are what made up this little communications session. So it looks kind of simple on the screen until you look at the actual packet trace. So that's one way we can actually look at any kind of TCP traffic. We can follow the TCP stream, and I'll show you some more about that in our next session when we talk about Telnet.